And my first announcement is that I sent the class an email yesterday. Did you see it? Okay. If you didn't check your email, that's cool. Do. Okay. You need to, because it was a full email and it had a lot of very important information. And, you know, one of the things that I want to stress is that, you know, I try to be very regular with making all of the announcements in terms of when things are due and when, you know, where we're at and everything. But I need you to read the emails, especially if you're not able to make it to class, because that's how you're going to get the information. So I just want to start out by saying that if you have not checked your email, you want to check your email. It has all the due dates, and most immediately, the activity number 3 is due by the end of class tomorrow. You can either bring it to me here physically, in which case I will physically grade it and give it back to you, or you can email it to me. But if I don't get it via email by the end of class tomorrow, I make the solution visible. So, okay. So I want to keep going with the material. We finished lesson 4 yesterday. And what I was going to do is start lesson 5 today. And my hope is to talk about lesson 5 today, tomorrow, and then whatever part of Friday is needed. I strongly suggest you do the test review that's on Moodle when you have a chance. And we'll talk about that also on Friday, because hopefully this isn't news. Your first test is next week on Monday here, okay? So those of you who Zoom in and or who have time constraints about being here for the full time, you need to contact me. Someone in this class already has contacted me because they can't get here by 10. So we've already scheduled it. Like, I'm happy to work with you next Monday. Like between 11 and 1 or after 3, but we got to schedule that, and you got to let me know now. But we have to do that by email, not verbally, because I keep everything written down with my calendar. And so if you could just send me an email, that would be great. Did you have a question?
I was wondering, like, is it possible to do like 5 minutes?
Yeah, you can, I mean, if you finish the test in 20 minutes, you can leave in 20 minutes. Yeah, I don't require that you stay here for the full time. As far as I'm concerned, take the test, and if you can get out of here early, I mean, it's more fun being outdoors than it is being indoors. So, yeah. Okay. So, I hope you're all doing well. And it's supposed to be really warm out today, so that's kind of exciting too. What I want to do is this final section before we take our first test. And again, I will talk about the test on Friday. I just want to be very forthright and tell you all that I'm not out to trick you. Nothing on the test is going to be a surprise, assuming that you've come to class, engaged in class notes, engaged in our activities, and that sort of thing. I really try to give you every opportunity for you to show me what you can do. Yeah? I'll certainly be happy to answer questions on that. Yeah. All right. So, y'all ready? There's two things we're going to be doing in this section. First thing I'm going to talk about are trees. We just barely looked at trees back a couple sections ago. And we're going to take a bit of a deeper dive into them in this section. And then after our test next week, we're going to then we're entering the deep end, okay? So the trees are the first thing that I'm going to address in this section. And then the next thing that I'm going to address are counting probabilities. And really what the counting probabilities require is that you're somewhat comfortable with combinations, okay? We're not really adding on very much, but we're putting two things together, okay? Are you psyched? Great. Okay, so let's talk about candy. Let's say that we have a bag that contains M&Ms, and specifically contains 3 blue and 5 red M&Ms. Okay, so I'm going to tell you that 2 are selected at random without replacement. Okay, what I'm doing with this example is I'm kind of motivating how we determine the probabilities and the like. When it comes down to being pragmatic and what sort of test questions are we going to have? Number one, you'll see it on the test review that's already been posted to Moodle. And number 2, I will let you know loud and clear. Kind of like yesterday when I let you know loud and clear that there's a Venn diagram question and also a table question, okay? I don't leave anything to the imagination in terms of what you're responsible for knowing for the test.
Hey, Lauren.
Yeah?
How many questions are going to be on the test?
I have to look.
Cool.
I have it written, but I will talk about that on Friday.
Awesome. Sounds good. Thank you.
Yeah, no, thanks for asking. I'm sure you're not the only one who's curious about it. It's totally doable within a 50-minute period. I make sure of that. So, all right. So let's talk about this. What does this look like? Well, here's my bag. And here are my 3 blue M&Ms. And those are my 5 red M&Ms, okay? So what I wanna do is actually make a picture of this process. So what we're doing is we're gonna pick an M&M and then we're gonna pick another M&M, okay? So do you agree when I pick my first M&M, it could either be blue or red? Okay, let's get into this story, okay? We got a bag, we got 3 blue, 5 red, we're picking an M&M. And then we're gonna pick another. Do you agree my first pick, it could be blue or red? What's the probability that the M&M that I pick is blue? It's 3/8, good job. Why? Remember, probability is the number of ways it can happen divided by the total number of possible outcomes. What is the probability that my first M&M is a red? 5/8. Can I show you something cool? What is 3/8 plus 5/8? 8/8 or 1. Okay, notice these 2 branches add up to 1. That's the total probability, right? Total probability you can have, a guarantee is 100%. All right, so now let's take each scenario. Suppose my first M&M that I pick is blue. Okay, I'm not putting it back. So now I'm going to pick another M&M. Do you agree that it could either be blue or red? Okay. Now, given the fact that we don't put this M&M back, what is the probability that my next M&M is blue? Close. I claim it's 2/7. Why is it 2/7? Well, notice I already picked a blue M&M, so there were only 2 left, and I already picked an M&M, so there were only 7 left in my bag. What is the probability if the first one is blue that the second one is red? It's 5/7. Good. Notice I hadn't picked any red M&Ms out, but I had already picked an M&M out, so I only had 7 to choose from. Notice 2/7 and 5/7 equals 1. All right, now let's go to another scenario. Suppose the first M&M that I picked was red. Well, my next M&M could be blue or red. Okay. How many blue M&Ms do I have in my bag since the first one was a red? I still have 3, but how many total M&Ms were in my bag? 7. And given that my first one was a red M&M, how many reds do I have left? 4 out of 7. So again, I want you to note that whenever we have this tree, that the sum of the branches equals 1. So do you agree that I have 4 different tree branches here, essentially? My first branch is blue and blue, right? I could write that as B intersect B. My second branch is that I have blue and then red. So we could write B intersect R. What is this one? R intersect B. And the last one, R intersect R. And intersect means and. You with me there? So what if I wanted to know what is the probability of B and B? Okay, well, we talked about this before. And tells us one operation or tells us another. What does and tell us in terms of like addition, subtraction, multiplication, division? Multiply. And or tells us addition. Don't forget those. Remember, I know I say these things a lot, but when you have and, it means intersection and multiply. When you have or, it means union and add. You with me? Cool. So what we do is we multiply across the branch. So if I want to find the probability that I pick 2 blue M&Ms, what I do is I multiply across the branch. I get 3/8 times 2/7. And we could say that's 6/56. As far as I'm concerned, on a test, you could leave it like that. Online homework would want you to reduce your fractions. Questions on this?
Yeah, how do you know when to stop the branches?
How do you know when to what?
Stop the branches. So like you have the 3/8 and then 2/7. Wouldn't we have to keep going to like another blue and then another red?
No, because we're only picking 2.
Oh, okay. Yeah, never mind.
If I was picking 3, yeah, then we'd have to keep going. I won't give you, on a test, I would never give you a bigger tree than this.
Cool, thank you.
No, thank you. I love your questions. All right, same tree, but now we're going to look at what is the probability that the second M&M is red. Remember when we were doing the combinations, I told you a couple things. One, I told you to talk to yourself. Okay. And two, I told you to translate. Those instructions carry over here big time. Okay. So what does it mean that my second M&M is red? What are my possibilities? Well, it could be a blue and a red, or what's the other possibility where my second M&M is red? Red and red. You with me? All right, so let's talk about this. Blue and red, 3/8, notice and, so times 5/7. Or tells me what operation? Plus, how about red and red? 5/8 times 4/7. So we could say then it's 15 over 56 plus 20 over 56, which is 35 over 56. And you could reduce that to 5/8. You wouldn't need to on a test. You with me this far? Okay, so again, I know that I keep emphasizing like our magic words and key words, but I'm doing that because it's going to help you. Okay, so these are things to keep in mind. And remember, on your test, you get a sheet of paper with notes. Maybe write that on your sheet of paper with notes, you know, whatever helps you. So now what I want to do is I want to show you a tree in general. Same scenario. Okay, but what I want to mention is in general, when you're talking about trees, you put the probabilities on the branches. Okay, so notice on this first branch, I had the probability that it was blue. On the second branch down here, I have the probability that the M&M was red. Okay, now how do we write this one? This is the second step branch. What I claim is this out here is the probability that it's blue, given that the first one was blue. Do you agree with me? And this one is the probability that it's red, given that the first one was blue. The way we write that is probability of blue given blue. So this vertical line is given that. And this one, we would say that's probability that the second one is red, given that the first one is blue. And this one would be the probability that it's blue, given that the first one was red. And this is the probability that the second one is red, given that the first one is red. Again, this line means given that. Now, what I want to say here is on tests, I don't ask you like, find the probability of red given blue, okay? I write it in words. The reason being that you're all taking this class because presumably you're going to be applying it to whatever area of study you're going to be looking at. And in your area of study, they're not going to be using this notation. They're going to be using words. And so the key thing for me is to put it in the context that's relevant for all of you. But what I want you to note is the difference between this versus that. This is the probability that it's red, that the second one is red, given that the first one is blue. Okay, that, my friends, if we want to look at these numbers, the second one is red, given that the first one is blue, is 5/7. This one is saying find the probability that the second one is blue, given that the first one is red. And what's that value on our tree? What's that movie? Ferris Bueller's Day Off. Did you see that movie? Anyone? Anyone? Anyway, that's what I think of when it's totally silent. What is the probability the second one is blue, given that the first one is red? 3/7. Hooray. Okay, so what I'm showing you is this notation. And I want to say that when you have the probability, say, of A given B, this one happens first. And we write that as the probability that event A happens, given that event B happened. And again, you don't have to memorize this whole thing. You know, you have a sheet of paper with notes. But what I want to say also as a summary is if you want the probability, and this is very important because this is how you're going to solve a lot of these. If you want the probability of a full branch, multiply across the branch. That, my friends, is the magic of the word and. Okay. So let's now talk about apples. Okay, sound like a plan? Let's suppose I have a basket of apples. Hold on 1 second. I want to look at one thing real quick. Awesome. Oh, you guys, this is so great. Okay. So suppose we have a basket of apples, and in my basket, I have 6 red apples and 3 yellow apples. And suppose a sample of 2 is selected. Now on the test, I won't ask you to draw a tree diagram. I'll already have the tree diagram for you. Okay, so again, if you look at the test review, you'll see that it's something very similar. Okay. All right. So first thing we want to do is we want to draw a tree. With the associated probabilities. Okay. This is going to look very much similar to what we just did with M&Ms, but now we have red and yellow because we're talking about apples. Okay, so first stage, what are my choices? I'm picking an apple. What could it be? It could be red or yellow. What is the probability that the apple that I pick is red? It's 6/9. If there's a question how I got 6/9, you got to ask me. The only bad question is the one that you don't ask. Okay, what's the probability that my first apple is yellow? It's 3/9. There's 3 yellows out of a total of 9. Okay. Now we picked one. It's set to the side. I'm ready to eat it. Okay. So now I'm going to pick another apple. How exciting. Do you agree it could be red or yellow? Okay. So what is the probability that the second one is red, given that the first one was red? Well, how many red apples do we have left in the basket? 5 out of 8. Notice this probability changed because we had already picked a red apple out and it was to the side, so we only have 5 left, and we picked an apple out, so we only have 8 left. What's the probability that it's yellow?
3/8.
Beautiful, 3/8. And if you were too lazy to look up above and you felt confident with the 5/8, you could just say, well, 5/8 plus what equals 1? 3/8. All right, now let's jump down here. What is the probability that the second one is red if the first one was yellow? 6/8. And therefore, what would this one be? 2/8. All right, so now that we have this wonderful tree drawn, let's find, how about 1, 2, let's find 4 probabilities, okay? And what I'm gonna say is after I do these 4 probabilities, I'll then take questions on the class activity that's due tomorrow. And then tomorrow, what I'm going to do is combinations with probability. And so I believe that Friday we'll have the entire data review for the test and ask questions. Isn't that great? Okay, so let's go through 4 probabilities. I love it when we can go at a nice clip. Find the, how about let's find the probability of drawing 2 red apples. All right, so we got to ask ourselves, where on the tree do we have 2 red apples? Is there one branch that gives that? Is there more than one branch that gives that? Talk to me. There's only one branch. There's only one branch. I hate my voice. No, I do. Don't you hate hearing this, your voice recorded? Isn't that funny how we are? Okay, so the probability of drawing 2 red apples, that can only happen in one branch. That's red and red. Oh, I translated. I got my magic word and tells me multiply. So I have 6/9 times 5/8. So I get 30/72. And yeah, you can reduce that. On a test, you won't have to. And I would just leave it alone. Like I wouldn't bother dividing, getting a decimal, or changing it to a percent. Are there questions? Okay. Now, I want to show you that this is the probability of red and red. I'm going to use English when I ask you questions. Some people want to see the notation. Does anyone here want to see what the notation looks like?
Yeah.
Okay. So when you're finding the red and the red, it's this branch, which is the probability that your first apple is red, times this branch, which is the probability that the second apple is red, given that the first apple is red. Okay. I'm not going to ask you questions like this on the test. You'll see some on your online homework, but okay, Next probability. How about, let's find the probability that the first apple is red and the second apple is yellow. How many branches can that take place with? One branch, right? First one is red, second one is yellow. So what we would do is we would take 6/9 times 3/8, and you get 18/72, etc. If you wanted to see the notation, now we're doing probability of red and yellow. So we take the probability of red, and then the probability of this branch is the probability that the second one is yellow, given that the first one is red. If the notation messes with you and you just think it's terrible, awful, don't look at it. Okay. Ready? Y'all with me? Okay. I just want to make sure that like my caffeine isn't controlling the speed of this class too much. Green tea will get you every time, right? Okay, let's now, these get more involved. Let's find the probability that the second apple is yellow. Well, this is where my second apple is yellow, correct? Can't that happen in more than one way? Right? I could have a red and a yellow, or I could have a yellow and a yellow. So red and yellow is 6/9 times 3/8, or tells me plus, and how about yellow and yellow? 3/9 times 2/8. So you get what? 18/72 plus 6/72, which is 24/72. And I'm not going to bother reducing it. Cool? Okay. One more. Let's now find.
Can you go back a second?
I sure can.
Thank you.
Yeah. Tell me when you're ready for me to move it.
I'm good.
Okay. Thanks, Sally. You're awesome. I appreciate you chiming in, for real. All right. Now, what if I tell you that I want you to find the probability that one is red and one is yellow? Is there one possibility, more than one possibility? What are you going to tell me? There's more than one possibility. Notice here, I'm not saying I want the first to be this and the second to be that. I just want one of each. So do you agree we could have a red and then a yellow? What's the word? Or a yellow and a red. So red and yellow is 6/9 times 3/8, or tells me plus. Yellow and red is 3/9 times 6/8, and you get 18/72 plus 18/72, which is 36/72. Which I've just got to reduce because if I see 1/2 in front of me, it freaks me out not to do it. All right. So, what I'm going to do tomorrow is I'm going to talk to you about, I'm not done for the day, but what I'm going to do tomorrow is I'm going to talk with you about the combinations. Okay, we're still going to do all the combination stuff. So make sure you get this lab activity 3 done and you're solid with it, because I'm going to assume you know how to do the combinations. All we're going to be doing is adding 1 extra step, because instead of asking in how many ways, we're going to be finding the probability. So that just means we've got to divide. Okay, so it's pretty much the combinations. We're just adding 1 extra step. All right, so just to reiterate, what I'm going to do is I'm going to take questions now, and then tomorrow I'm going to finish up lesson 5, and then on Friday we're going to I'll take questions and we're going to review. Sound good? All right. So, what are your questions? Yeah. D. Yeah. Okay. Remember, this is due by class tomorrow. So what do we have? We have 7 pea plants, 4 radish plants, and 3 corn plants. And we're selecting 4 of them. Okay. Would you grant me that the order doesn't matter? Right? Because we're still just going to play with those plants. Well, in this one, we want to find the probability of selecting at most 1 radish. Hey, whenever you have at least, at most, no more than, no less than, you want to be open to the idea that there might be more than 1 possibility. Okay? What does at most 1 mean? 0 or 1. So what we're saying here is we could have no radishes, or we could have 1 radish. Remember, our first job is to translate in the context of the question. Okay? My next step is to then account for the rest of my sample. Okay? How many total plants are we selecting? We're selecting 4. So do you agree if there's no radishes, there's going to be 4 others? We don't care whether they're pea or corn. Just lump them together. If there's 1 radish in my sample, what do I know? That there's 3 others. Remember, the first thing is translate. The second step is account for the rest of your sample. You with me this far? All right. So let's write this out now. Notice or means add. Well, I'm talking about radishes and others. So at the top, you put the total number you have to choose from. How many total radish plants do we have? 4. How many other total plants do we have? 10. Right? You can't count those radishes because then you won't have no radishes. Okay? And in this case, we wanted no radishes and 4 others. Now, we still start out in this scenario with a total of 4 radish plants and 10 other plants. But now how many radishes do we want? 1, and how many others? 3. Did that help? Do you like it? You don't have to. I love peas and corn and radishes, so we can just like the plants. Yeah. 1B. Ooh, good. Okay. You can solve it. Yeah, on a test you don't, but on a worksheet I would ask you to. All right, so 1B. So let me just read the question number 1. 6 good hitters and 7 poor hitters try out for a 5-person baseball team. Okay. So part A is part A. Part B, 5 people have been selected. Okay. We got the 5 people on the team. You with me? So given that we have 5 people that have already been selected, how many batting orders are possible? Does order matter when you're talking about batting orders? Heck yeah, it would make a big difference if I went first versus if I went last, especially because I'm terrible at baseball. Okay, so here order matters. Well, we have 5 total people. How many people could go first? 5, but someone's going to go first. So how many people could go next? 4, then 3, 2, 1. Blast off. 120. Yeah. 2C? Yeah, happy to. All right. So 2C, well, let me do 1A because we were just doing number 1. Oops. Okay. Here, we just want to know in how many ways can the team be selected. Notice the order doesn't matter here. So how many total people do we have? How many people do we have to choose from here? 13. And how many do we want to choose? 5. All right, so now 2C. We want exactly 2 pea plants. Okay, we want 2 pea plants. My next step is to account for the rest of my sample, right? Well, I'm picking a total of 4 plants, so what does that tell me? And 2 others. We don't, again, differentiate between them being radish or corn. We just want to talk about peas and not peas. So, do you agree we have a total of 7 pea plants and we want 2? And how many other plants do we have? 7 and we want 2. So you would compute 7 choose 2 times 7 choose 2. No, not quite. Because then what you're saying is that you want exactly 2 pea plants, 1 radish plant, and 1 corn plant. Then you've computed what we wanted in part B. Great question. I really appreciate all of you. Like, I just love your questions. I love the fact that you ask questions. Yeah, it warms my heart and it makes my day. So thanks. All right, I will see you or Zoom you tomorrow when we will finish up lesson 5. I hope everybody has a super awesome day today. Thanks.